Alright, here's some tips on solving the practice work that's in class for today. Sorry again that I'm not there, but this gives you some good time to catch up and practice. First question is the diving question with Mr. Thompson, and you set up your equation with your A. All of this is in standard form, A being negative 16 for the effects of gravity. The initial velocity is 5 feet per second, so it's 5x, and he starts at 92 feet high, so it's plus 92. I have it there in standard form of the y and x, but since ours is height versus time, you can change it to a function of h, or h of t equals negative 16t squared plus 5t plus 92, where the t is time and the h is the height. There's the graph for later. We started at 92 feet, so we can mark that off right away. Alright, step 1 is to find the vertex. Boom, so we find the vertex by using negative b over 2a. In this case, instead of x or h, we use t, because we're supposed to find time. So we plug in our 5, our 2, and our negative 16. We get that to be negative 5 over negative 32, which is 0.16 seconds. So it takes 0.16 seconds to hit the highest point on our path. And take that point 0.16 and plug it into our equation. And that's what you have there in blue. So instead of t, I plugged in 0.16. If you work it all out, there's a second step. And then finally, the highest point is 92.38 feet. And I put that in blue on the graph. There's our vertex. Step 2, use the quadratic formula to find the x-intercepts, or in this case, when Mr. Thompson hits the water. Alright, so we plug in all our numbers. Take a second to see if that's what you have. And I work it all out. You get a big large number in the square root, 5,913. But square rooting it brings it to a smaller number of 76.9. You'll get negative 2.24 and 2.56. In the real world, the negative 2.24 doesn't help us, so it is only the 2.56 that helps us, because that makes more sense. This makes more real world sense. This makes more real world sense. So we plug that into our graph, boom, and graph that, and that is the path of Mr. Thompson's dive. Alright, thank you, and I'll see you in the next video.